Good day, ladies and gentlemen. This is Sarah van Grinnen, aka Mr. VG, and I'm now at video 3, looking at a beautiful question that was asked in this exam about algebra and exponents. Sorry for my long pause. It kind of felt like I was about to start a new sentence, and then I just carried on with the same sentence. But we are specifically going to look at simplification with a little bit of factorization involved there as well. Now, we love to ask these questions in grade 10, and sometimes some teachers can become really nasty when it comes to simplification and factorization. And I decided to ask these questions, and I don't think it is that difficult, but it needs that you know your theory. You must know your tips and your tools and your techniques so that you can simplify and factorize these sums. So when we look at this, there's also a question 2C, but that one we're going to do in the next video, depending on how long this video takes, okay? But let's start with you attempting question 2A and B. Once you have attempted this, please look at the rest of the video. When I look at this, simplification means make smaller, make it easier to work with, okay? So what I always think about is removing brackets, getting rid of brackets, etc., okay? But also sometimes simplification is going to require factorization. But let's start with question 1. What is your instinct? My instinct is just remove the brackets. So I'm going to simply distribute that x squared in as well as the -1. So I'm going to put in an in-between step for you, saying let's distribute that x squared in as well as the -1. Now I'm multiplying out x squared times x to the 4 times x squared times by x squared and x squared times 1. The same with the -1. I'm distributing it into the back bracket. And oh man, there's so many terms that just poof, go away. Which means I'm left with x to the 6 minus 1. Now, if you were a clever cookie, okay, a clever little cookie, you might have seen that, but sir, isn't this that funky factorization? Yes, it is the funky factorization you must have done in grade 10. And what was it? Let's quickly go. If I look at this, that back bracket, okay, if I take the x squared minus 1, first of all, taking the x squared and squaring it, does it become x to the 4? Yes. What about the middle term? I take the x squared and I times it by the -1 and I change the sign. So that becomes positive x squared. And then the last term in the back bracket is squaring that -1. But that's exactly the back bracket there. Then we can simply go to the shortcut which says this is x squared to the power of 3 plus -1 to the power of 3. So it is actually a difference in cubes, which gives me x to the 6 minus 1. Now, I do want to warn you, ladies and gentlemen, sometimes we as teachers, we are nasty human beings, okay? Not really nasty, but we can be quite nasty because what we do is we just change one thing in the back bracket a little bit. So it's almost a shortcut. Then you have to be able to take the long road of distributing one by one from the front bracket into the back bracket, okay? So please be careful of using this shortcut. Please, please, please be very careful, okay? Let's look at the second question, A2, okay? Simplify that fraction. Now that, because it is a fraction, and we're asking you to simplify, I'm going to actually first factorize before I do anything else. So if I want to factorize, I must first get rid of the divide. So I'm going to KFC. If you've never heard about KFC, oh, I love KFC, this beautiful shortcut, which is keep, flip, change. Okay? Now, I don't know that some teachers don't like that. They want to go all mathematical on this and go, it's reciprocating. It means exactly the same thing. Okay? So, in other words, I'm going to keep the one in front of the divide exactly the same. I'm going to flip the thing behind, the term behind the divide. Okay? I'm going to flip it. Beautiful mathematical term, reciprocate. Okay, reciprocate. Okay, and I'm going to change the divide into a times. KFC. Okay, keep, flip, change. Oh, love it. I know some teachers, you know, if you are a staunch mathematical person, this is not going to sit well with you, okay? Then you can just go make the divide into a times and reciprocate your back term. So when I look at this, now I need to factorize. So that first factorization is a trinomial, so I'm going to say 3x times by x. And also I'm going to say 5 times 1. But now because I want to go to a negative, my spidey sense is telling me that my 5 must be a negative and the 1 must be a positive. Now it's always good to check whether it's right. Okay, 3 times by 1 is 3x and negative 5 times x is negative 5x. Does that, if I add it together, give me negative 2x? Yes. So I know I'm right. Okay? But let's carry on. Over 3x, and I'm timesing by the 1 because I didn't do anything with those two, with that denominator and that numerator. But I can take out a 2x common in the bottom or the right denominator, and therefore now my 3x minus 5 and the 3x minus 5 is going to divide away, and I'm going to multiply the top and I'm going to multiply the bottom. So I multiply the numerators and the denominators, leaving me with x plus 1 over 6x squared. And that's my answer. Is it simpler than what we started with? Definitely, ladies and gentlemen, definitely. Okay? Now let's quickly look at the next question, A3. Now we're sitting with an exponential sum. Okay? Looking at an exponential sum where there are only multiplications and divisions. So now, before I do anything, let me get a game plan going. What is my game plan? I'm going to make the bases equal, specifically prime numbers, and then I'm going to apply the exponential laws. Okay? So that is how I'm going to work with multiplication and division. So I'm going to change the 9 into 3 squared, the 6 into 3 times 2, the 18 into 2 times by 3 squared. This I'm going to, for the sake of time, I'm just going to show you how I substituted them in. So in the place of the 9s, I go 3 squared in brackets. In the place of the 6, I put in brackets 2 times 3. And now I need to distribute that 2 into the x minus 1, okay? And do the same with all the other exponents, because that is law 4. Again, for the sake of time, I'm going to just go and show you the first one. So 2 to the 1 times by 3 to the 1 is going to be 2 to the x plus 1 times by 3 to the power of x plus 1. And now I'm going to repeat that process in the denominator. So I'm going to take that 2, the 3, and multiply it by x, and the same with that 3. I wrote out the 2 times by 0.5x, okay? Which is then going to become x. I wrote it out so you don't think that things just poof, disappear. But I multiplied the exponents with each other. This then, in return, ladies and gentlemen, is going to lead me towards applying law 1. So I'm going to multiply the 3's there. By multiplying the bases, I'm adding the exponent. Remember what law 1 says. If they have the same bases, I add the exponents. So 2x minus 2 plus x plus 1, and in the denominator, 2x plus x. Which means at the top I'm sitting with 3 to the power of 3x minus 1. And at the bottom I'm sitting with 3 to the 3x. Can I now apply law 2? Yes, because there's a divide. So I'm going to apply law 2 with my 2's on the one side. Okay? And I'm going to do the same with the 3's. Now you will see that I put the bottom exponent in a bracket. Please, please, please do this, ladies and gentlemen, so you don't forget if there's more than one term in your exponent that negative counts for everything in the second bracket, okay? Same with the 3's. Going to take the top exponent minus the bottom exponent. Always top minus bottom. This leads me to 2 times, or 2 to the power of 1 times by 3 to the negative 1. Please be careful. You've got to leave your answer with a positive exponent. So in other words, that 3 to the negative 1 is a problem. So I'm going to make it 1 over 3 to the 1. Now I'm left with multiplying the denominators and the numerators by each other, and I'm left with 2 over 3. Easy, easy, easy. Okay? Now, let's look at factorization. I'm asking you to factorize the following completely. Now, there are 2 ways of thoughts, or 2 thought paths in this. I'm going to show you both. The first one is, let's put everything on the same denominator, okay? So in other words, use an LCD of 2. So I'm going to take that 8x and also put it over 2. Why do I do that? Because I'm working with fractions, okay? Now I need to factorize the denominator, or the numerator, I mean, okay? So taking out an x common, now I'm left with a difference of 2 squares in the bracket, okay? That difference of 2 squares is going to give me x squared plus 4 and x squared minus 4. Remember, you're not done. Now I need to repeat the process with the x squared minus 4, not the plus 4. That's not a difference of 2 squares. So I'm going to factorize that x squared minus 4 into x plus 2 and x minus 2 over 2. That is the way I would show my students how to do it. Now, but most teachers would use the second method, which says, but can't I just take out a half x common? You can, but I know most of my students will mess this one up, okay? Because that taking out a half common is a weird concept, okay? You guys are not used to taking out halves or quarters, but it's not impossible. So remember what happens when I take out a half x common. The first term is very simple. That's just going to become x to the 4. Most of my students, no issues there. The problem is with the second term. The second term is now, remember, when you're taking out common, it means taking the 8x and dividing it by whatever you take out common. So I'm going to have to divide by a half x. Please be careful. First of all, the x's are going to divide away, which is fine. This leaves me with a half x times by x to the 4 minus 8 divided by a half. What is 8 divided by a half? That is 16. Huh? How did I get that? Think about what divide means. If I take 8 oranges and I divide them into halves, how many halves will there be? 16. Or you can go keep, flip, change. So keep the 8 the same, flip the half becoming 2 over 1 and change the 2 times, and that gives me 16. But wait, sir, that's exactly where we sat there. Exactly what we had in the third step of my left-hand side, which means I can factorize the difference of squares. And now my first bracket, I can factorize further, leaving me with the same answer. Wow. I hope you enjoyed this video. I'm going to keep the C part for the next video, okay? So this is Mr. VG signing out. Please tune in to my next video, which is going to be about exponential addition and subtraction. Okay? Have a beautiful day. Keep well. Cheers.